From question 6, Caden picks up a stationary 10 kilo object at the bottom of the swing. What is the maximum height he will reach on the other side? Well, because of conservation of energy, his potential energy, which is what he started with, which is mgh, is equal to 75 by 9.8 by 8, which is 75 by 9.8 by 8. That gives us 5,880 joules of energy. So when he swings back up to this height, he's going to have the same amount of energy, 5,880, but he's now actually 10 kilos heavier. So that 5,880 joules of energy that he had is now going to be 75 plus 10 times by 9.8, because gravity's not going to change, but he's not going to go up as high. So height equals 5,880 divided by 85 by 9.8. And the calculator again. So 5,880 divided by 85 by 9.8. Close the brackets. And that's 7.058 or 7.06. Let's call it 7.1 metres. So not quite as high as originally. Next one. Young Rodney accelerates his car uniformly from rest. So U equals 0 metres per second. And after 12 seconds, T equals 12 seconds, he has covered 40 metres. S equals 40 metres. What are his acceleration and final velocity? V equals question mark. Okay, so looking at this, we've got, what can we do? S equals ut plus a half at squared. So S is 40, 0 times by time, so that'll cancel out, plus a half times by acceleration times by 12 squared. So that's gone. So therefore we have 40 equals 12 squared is 144. Half of that's 72, 72A. So A equals 40 over 72. 40 divided by 72. And that's equal to 0.56. 0.56 metres per second squared. So that's our acceleration. So final velocity then, we could use V equals U plus AT, which is equal to U, which was 0, plus 0.56 times by time, which is 12. Back to our calculator, the number's still in there. So if we times that by 12, we get 6.67. So 6.7 metres per second. And there are our two answers. Number 9, the car is being driven by Nathaniel along the road at 25 metres per second. He suddenly notices that there's a fallen tree blocking the road 65 metres ahead. So U equals 25 metres per second. S equals 65 metres, but that's 65 metres until a tree. Nathaniel immediately applies the brakes, giving the car a constant retardation of 5 metres per second squared. So A equals -5 metres per second squared. Does he stop in time? If so, how far before the tree? Okay, so we've got to work out this one here. Okay, that's how far the tree is away from Nathaniel. So the final velocity must be 0 if he comes to rest. So what can we do there? we've got v squared equals u squared plus 2as. So 0 squared equals 25 squared plus 2 by -5 times by s. 0 equals 625 minus 10s. So 625 equals 10s. So s must equal 62.5. So in answer to the question, yes, he does stop in time. Yes, he stops in time. So to get a mark for that, you must say, does he? You have to answer that. Yes, he does stop in time. If so, how far before the tree? Well, if the tree was 65 metres away and he managed to stop in 62.5 metres, that means it's 2.5 metres before the tree.